the AXISVM X8 launch webinar. Today we are going to see the updates that the new version of AXISVM will bring to engineers, and we'll hear presentations about the latest module, the construction stages module, and also the updates for the existing design modules as well. Just FYI, for your information, this session will be recorded and the recordings will be shared after the webinar itself. We'll have a Q&A session at the end of the presentations and the webinar. So if you have any questions, feel free to add them in the chat and we'll answer those at the end of the presentations and the webinar itself. I think that's going to be it from my side. I will hand over the microphone to my colleagues. Our first presenter will be Roland Doka, who is going to talk about the new construction stages module that X8 brings to engineers. Thank you, and I will invite Roland onto the stage. Just 1 second. Invite on stage. Yes, thank you so much.
Hello, everyone. My name is Grasshopper. Thank you, Daniel, for the introduction. And I'm happy to see that a lot of people are here. I think in recent times, this is our most crowded webinar. And I hope you will like what you will see, which is the following. First, we will go through and I will present you the new construction stages module in AXISVM X8. Then my colleagues will join and they will present you the design module improvements in AXISVM X8, new features in soil, wind module, and a new version of the Grasshopper to AXISVM add-on. And at the end, I will close off this meeting by showing you the new display options in X8. So in the next 20 minutes, I am going to give a brief high-level overview of the construction stages module itself. And starting off, let's start with the goal of the module. What was our aim with this module, which was to model the construction and demolition processes to be able to account their effect on the redistribution of internal forces and stresses, and to able to integrate them into the design process. Let's see what gives the significance of construction stages module itself and the handling of construction stages itself. It is basically that the structure is exposed to conditions different from the operational state during the construction process. And that during conventional modeling, we are building one model, including all the loads and structural elements simultaneously, which is not the case in real life because structural elements are built gradually. Their self-weight is added incrementally during the construction process. Next thing is that during the construction process, the boundary conditions often changing. So at one point of the construction process, certain supports can be present in the model and others are inactivated during the construction process itself. Another thing is the material deponations. So temporary loads during the construction can appear and disappear, which can have a significant effect on internal forces, stresses, which should be taken into account in certain cases. And the other one is the deformations and settlements, because during the construction, the deformations are compensated, and this phenomenon can be accounted with the STG module. Settlements and deformations due to self-weight may cause significant forces and stresses in elements that have not yet been built. And there are also time-dependent material properties. Reinforced concrete has different properties in, let's say, in 7 days age and in 28-day stages. Very high-level overview of the method, what we have implemented into the software is the following, that our model needs to be grouped into construction stages during the design process. So this will be the first step when we are working with the new module. We will create construction stages, and then we will fill these construction stages up with elements. We will activate them, deactivate them in each stage, and also we can modify their properties, so we can strengthen or weaken elements according what are happening to these elements during the construction process. And we not only need to assign elements for these stages, but we need to assign loads as well. So we will assign loads to construction stages acting in that specific stage as well. And after that, we will perform a statistical calculation for each of the stages. And by evaluating the results for each stages, we can track the development of internal forces from stage to stage. Construction stages is a very deeply embedded module, let's say, in AXISVM itself, which influences the workflow of the design process itself. And from now, if you are working with construction stages module, you will have a bit different workflow to be applied than, let's say, during the conventional design process. So first, we will need to start a master model, which is a principle what you should take away from this webinar. What is the master model? Master model is itself a model which includes all temporary and permanent elements and loads also. That means that all supporting structures which only present in a certain construction stage has to be presented or modeled in this master model. But the master model itself, in general, is built up with the usual features from the geometry, elements, and loads tab. So nothing new there, but the concept of the master model is important. This picture shows an example for a master model. So there is a reinforced concrete structure which includes columns, slabs, ribs, which are the final state of the structure, let's say. So this is present in the operational state of the structure, but there are also supporting parts, the steel supporting beams, columns as well, presented in this master model. This is what we build first, and then we need to define the construction stages. The features linked to the construction stages function module itself are all organized into a new tab, called the construction stages tab. And here we can assign elements and loads as well. And as well, we can make a lot of modifications for these elements. We have different display options. We will go through on them later on this presentation. An example for the previously shown master model is that master model was broken down to 4 or 5 construction stages. The first one is where we built the columns. Second one is where we built the beams, slabs, and the supporting columns. Third construction stage is the first story reinforced concrete columns. And in the fourth construction stage, the slabs and ribs were built alongside with the supporting beams of the first floor. And then the final construction stage, the 5th construction stage, represents the final state of the model. And there is one important difference between the final state and the 5th construction stage of this model, because on modeling level, this includes all the elements and all the structural parts of the model which will be present in the operational state of this structure. But loading-wise, there is a big difference between the final construction stage and the final state, operational state of the model. Namely, that final state, which is the operational state, considers all loads of the master model except temporary loads assigned for construction stages, while the last construction stage considers permanent loads and temporary loads assigned to that specific construction stage. And one more important difference is that certain load types can only be considered in the final state. For example, seismic loads are such type of load case, load group. Okay, so now we are standing at the point where we have construction stages, filled them up with elements and loads. And the next step is the calculation. The calculation itself is the calculation of construction stages. We calculate the construction stages as a series of linear static calculations. And we calculate the successive stages based on the difference between the loads in each stage. And by calculating the results, we can track the construction process using the principle of linear superposition of the results. Yeah, and we generate results for each phase, so you can check the result components for each of the stages, as well for the final stage as well. When we have our results, we can move on to the design phase, which does not include too much new features, so it's more or less the same like it was in X7 and in previous version. The only difference that you can perform design checks by construction stages, so you can check a certain element for every construction stage in which that element is built, and you can check them on the final state as well. And certain design modules are available only in the final state. So, for example, this includes, for example, so the whole list of available design modules available in the final state is available in our user manual. Not all design modules are available for construction stages, but the main ones, like the reinforced concrete modules, like the slab reinforcement, column reinforcement, beam reinforcement, for example, are all available. And for steel design, timber design, these modules are all available for the construction stages as well. But the whole range of design modules are available in the final state, where all of the loads are acting, which are present in the operational state of your building. All right, so let's see some practical examples. What can be modeled and can be handled with the construction stages. So first one, of course, is modeling the construction process itself. So if we are speaking about a steel hull, the erection of the columns, lifting of the roof structure, adding the secondary elements, and analyzing the effect of these incremental processes can be examined in a single model. We can model the demolition of we can model the demolition of the structure or partial demolition process of the structure. So we can remove elements and we can track the redistribution of internal forces and stresses due to these removals. And in these stages, we can check the structural stability of the structure during this demolition process. We can perform we can check retrofittings of structures, so we can strengthen them. For example, we can model retrofitting of steel sections. If you add plates to an existing section, and this way it is strengthened, you can make this into construction stages and check them. We can check jacketing of columns, replacements of walls and columns, and the list is more broader. These are just some specific examples. We can also model structural damages. So we can analyze damaged or failed structures. We can assess material defects such as corrosions, and we can assess the remaining load-bearing capacity of the structure. These are handled indirectly, basically. So we have the tool set already there in AXISVM. We can define reduced cross sections and apply these cross sections for certain construction stages where you want to model that a steel cross section is corroded, and you want to model the decrease in load-bearing capacity by this. We can use the construction stages in situations where the support conditions are changing during the construction process. So bridge launching process is one example. And we can also analyze structural robustness or support the analysis of structural robustness and the possibility of progressive collapse. So with the help of the STG module, we are able to perform quasi-static analysis within a single model of the structure's robustness using the so-called notional removal method. This involves selectively removing key elements to observe the structure's response to determine whether it can maintain stability after the redistribution of internal forces. And in this way, the module can indirectly support the planning of structural redundancy. So this was a brief overview of how this module looks like, how you have to imagine it. And now I would like to show you two examples for which I will share my screen. And the first model what I have brought you is a very simple model. This is the most generic example what can show you the difference between the conventional analysis and the effect of the conventional analysis and the effect of using the construction stages module. So this is a multi-story reinforced concrete structure where all of the floors are loaded with a uniformly distributed load. We have only one load case. We don't need to go into details too much. The fact, I mean, the important thing what we should note that if you model this kind of structure with the conventional approach, and you check the deformations, z-directional deformations of this structure, you will see that the deformations are growing from bottom to top, and this is because the upper floor displacements already includes displacements from the lower levels, which is of course not the case in a real life situation. And to handle this, we can use construction stages module. And how you do this, I will show you in the next example, which is starting from the same point, what you see, what I was presented before. So this is the same model. And first, I will show you how you will build up construction stages. This is itself the master model. This is because we don't have elements removed and we don't have temporary elements. This is the same model as it would have been in previous versions of AXISVM. So we can move to the construction stages tab. So this is the tab where all of the features regarding linked to construction stages are presented. And when you first come in here, you will only have one button active, which is the construction stages button. And if you click on it, you will see this dialog. This is the main dialog where you can define construction stages themselves. So without bothering too much with the namings, I will quickly create 7 of these construction stages. All of them are listed in this table below. Here we will see that what kind of elements are being built or removed or modified in a certain construction stage, what loads are presented here, what loads are presented in this stage, and we can move them down or upwards if you want them. We can color them if you want, and we can export them into separate files. So basically, if you have a complex model and you want to export a specific construction stage into a separate AXISVM model, here you can do that. Right now, we won't do that, but this is an important option. All right, and if you click OK, these construction stages will fill up this drop-down menu, and suddenly the rest of the construction stages functions will become available. First, I will choose the first construction stage, and I will start adding elements to this construction stage by selecting elements on the master model. And then I have build selected elements in this current construction stage button. If I press this one, seemingly nothing happened because right now I have the master model visible in the main modeling area. But I have an option to only show the elements present in the current construction stage. So if I click this one, I see that only this has been built in this current construction stage. If I move to the next construction stage, nothing is built so far in this stage. So again, I will switch to the master model view. I will select the next story, elements of the next story, and I will add these elements to this construction stage as well. And as you can see, now I have 2 construction stages filled up with elements, and I can continue doing this process, adding elements to later construction stages. I have the option to show only those elements which are built in this specific construction stage, no other. I can also show the elements modified in this current construction stage. No modifications has happened so far. And I can show only elements removed in this current construction stage. So these are the options you have when you navigate through the construction stages and navigate through that what elements and what modifications were made in these construction stages. And by this logic, you can fill up all of the construction stages. So let me switch to the model where I already filled up all of these stages. And if I go back to the construction stages dialog, you see that in each stage there are added slabs, ribs, trusses, and nodal supports. Next thing what we have to do is to assign loads to these construction stages. And how you do that, you have a separate button to assign permanent and temporary loads to construction stages. I already done that in this model, but you have the option to add permanent or temporary loads to a specific construction stage. Right now, I have one load group. I will add the loads to be acting as a permanent load during the whole construction process, which represents this uniformly distributed load. And after I've done that, the drop-down menu will contain this load, and each stage will show not only the elements presented in this stage, but the loadings as well. So now we have filled up all of the construction stages. We have assigned loads to these stages. Now we can continue with the analysis part. And when we do that, and we start the calculation, the software will ask you that, do you want to calculate all of the construction stages or only the final state, operational state of the structure? Of course, we need the all construction stages right now. And ask you if you want to get cumulative displacement results for X, Y, and Z direction. So the important thing here is that each successive construction stage is run only for the difference in loads, since the effects of the previous loads are already present in the structure. And afterwards, the results are superimposed. Due to the nature of the calculation, displacement results are not continuous between phases. However, it is possible to accumulate them in the 3 displacement directions what you have saw before. And of course, because this is a multi-story building, accumulating displacements in Z direction is meaningless in this case, because the goal itself is to model that the self-weight of the lower levels does not cause additional deformations on the upper floor. So this is the reason why I am going to neglect the Z directional cumulative displacements. After I click on the OK button, each of the stages will be calculated. And when it's finished, a separate .stg file will be written out next to your model file. These STG files contains the result result components and results for each stages. And as you can see, I have only created 7 of the construction stages, but the software automatically adds a last construction stage, which is the final state. And this is the operational state of the building, and this can include additional loads, not just construction loads, but the other type of loads, for example, seismic loads, wind loads, and such loads which can only be present in the final state of the structure. Okay, after I click on the OK button, let's check the results in the final state, deformations in the Z direction, field section line diagram from a side view. And let's put the original model here, which was the conventional approach. And as you can see, the deformations are now does not include the upper floor deformations, does not include the deformations from the lower stories. That means that the deformation on the top floor is now only 2.3 millimeters compared to the conventional approach is 3.1 millimeter. So this was the first model what I wanted to present you. The next one is a bit more complex. Which is a multi-story building. And with this model, I want to show you that how this construction stage model can interact with other modules. So for example, the soil module, how you can handle a more complex loading situation, how you can model construction loads. So loads linked to construction stages, and how you build a master model. So this master model is basically contains not just elements which will be present in the final state of the structure, but we have temporary elements as well. So these supporting columns under the slabs are not present in the final state of the model, but because we are building a master model including temporary and permanent elements, we need to include these inside the master model before we start calculating. Loading-wise, we have a quite complex loading schematics in this model. So we have permanent loads for the self-weight, for the layers on the elements. We have a load representing the partition walls. We have live loads for the stairs, for the offices, first floor, second floor, third floor, and we have construction live loads. So we have construction live loads on the ground floor, first floor, second floor, third floor, and on the roof. And we have material deponations on first floor, second floor, third floor, and as well on the roof. We have wind loads assigned, generated using the SWG module. And we have snow loads as well, which are also generated. And yet the model itself contains steel elements as well as reinforced concrete elements as well. So we have built up our master model, and we can move on to the construction stages dialogue. So let's see how is this model organized into construction stages. So the first construction stage, called initial state, only consists the soil modeling domain, which can be modeled with the soil module released in the previous version. And this is modeled because we want to take into account the initial state of the soil, and we have modeled the soil because we want to take into account the deformation differences between the supports, and we do not want to define stiffnesses for each of the supports separately, but we want to do that and assess the stiffnesses based on the soil deformation itself. So this is why we have used a soil modeling domain in this first state. The next construction stage consists the ground floor, which consists the slab itself, the foundation slab. We have columns, walls, temporary supporting structure. On the next phase, third construction phase, the first floor is built, and then the second floor alongside with the first floor staircase. And as we move on in the fifth state, next floor is being built. And on the sixth floor, as you can see, we have not only added elements, but we have removed elements. So we have in the sixth construction stage, we have removed some temporary supporting structures for the slabs. We have used the remove selected elements in this construction stage to perform that. And yeah, we already saw two types of actions, what you can do with elements. Actually, there are 4 of them. So you can add elements, you can remove elements from a construction stage, and you can modify elements. There are no elements being modified in this model, but just to show you how you can reach this function, is that basically for slabs, for line elements, for supports, you have the option to modify their parameters. So you have the option to replace them, and you have the option to modify elements, cross-sections, and materials as well. So if you want to take into account, for example, the corrosion effect of a steel section, you can create other cross-section which will be applied, a reduced cross-section, in a certain construction stage. All right, moving on to the next stage, we are building the roof and the rest of the staircases. And all of these elements which are being added, which are being removed, are now contained. This information is contained in the construction stages dialog. So as you can see, sixth construction stage has minus 12 trusses removed from the model. And we also have a timeline view of the elements. So basically here you can check that what kind of elements are being built in a specific construction stage. You can select these elements, and clicking on the selection button, you can see them inside of the 3D modeling area as well. What we are missing at this point is the loadings. So now if we go into the assign permanent and temporary loads to construction stages dialog, we have a bigger table than on my previous model. And here we need to assign permanent loads first. And for that, I will assign that the self weight is acting as the elements are being built. So they will act from the first construction stage. Layerings or weights of the layers will only added in the fourth construction stage. Partition walls will be built starting from stage 5. Live loads for the operational status of the building will not be added as temporary loads. They will only be taken into account in the final state, operational state of the building. But construction loads has to be defined. And for that, I will use the temporary loads option. By this, I am telling the software that I only want to take into account these loads during the construction stages and not in the final state. And clicking one by one on each cell, I can define that in which construction stages do I want to take into account the specific load case. So the pattern will be like this. If I'm right. Okay. So this is the pattern I am going to use for this specific model. And after I click on the OK button, I can track that in a specific case, what kind of loadings are there. All of them are listed in this drop-down menu. and I go through from stage to stage. Okay, everything is ready, and I can continue with the statistical calculation. This model would take around 5 minutes to calculate, so to spare some time, let me change to an already calculated model and check some of the results and how you can navigate through the results. So in the static analysis tab, on the first drop-down menu, which consists the the load cases, critical combinations, manual combinations as well. This is the place where you can select that what is the construction stage do you want to examine. So all of the construction stages are listed here, and in each construction stage you have the load cases which are present in that load case, and you have the envelopes and critical combinations which are created from the acting load cases in that specific construction stage. So yeah, so after you choose one load case, sorry, then the rest of the options are the same as before. So you can choose the result types from the drop-down menu. Let's say we want to check the Z-directional displacement components, and I want to, for example, examine these values on this floor. I can create a temporary submodel view for this one. Sorry, I wanted to show you the deformations themselves. Let's use this view. Okay, so fifth stage consists the temporary supporting structure, and if we move to the next stage, sixth stage, you will see that as they are being removed, the deformations are now according to the changed structural framework of the structure, and they are now the maximum deformation values are on the middle of these slabs. Speaking of design, the design process itself works the same like before. So for example, if we move on to the reinforced concrete design tab, we see that we already have some of the elements modeled, designed. So for example, we already have actual reinforcement defined for the slabs, for the beams, but just to show you that how you perform design for a specific type of element. And if I want to do this in the final state of the structure, I simply select them, click on the column reinforcement RC2 module, and the process is basically the same. Again, the difference is only that I can perform the column check not just for the final state, which I have started to work with, but I can choose each of the construction stages, and by that I can check the behavior in each of the construction stages. And if an element is not being there at the given construction stage, what you have chosen, for example, the first stage should not include this this element yet because it's not had been built. The program will notify you that this is not present in this current construction stage. All right, steel design works the same. We have a bit different dialog there. So for example, if I choose this element here, and if I click on it, I need to assign some design parameters. And after that, if we click on the element itself, it starts to calculate this element. And we receive this dialog which was present in the previous versions as well, where we can check the result types. I mean, so the checks for each of the standard checks. And again, if that specific element is not presented in a current construction stage, you will not see any results for that. And of course, design calculations are also available for each of the stages as well. So this is what I wanted to show you with these two models, and by that I am passing through the stage to my colleague. So if you have any questions, feel free to ask them in the chat, and we will try to answer them.
Thank you so much, Roland. Hope you like the new construction stages module that's coming out in X8. Just a small note that we're going to share a lot of content based on the construction stages module in the upcoming weeks on our social media channels. So if you're interested in this one and you are not a follower so far, then feel free to join so you won't miss anything. Additional side note that we received a lot of questions so far. We will try to answer as many as possible in the Q&A section at the end of the webinar, but I still encourage you to write in your questions in the chat, because if we won't have time to answer your questions in the Q&A session, then we'll reach out to you directly and answer those questions later on in the upcoming few days. Now, I'm going to pass on the microphone to my colleague Oliver, who will talk about the design module improvements in AXISVM. I'm inviting him onto the stage right now. And received, 1 second, invite the stage. Yes. And on to you, Oliver. Thank you.
Okay. Hello, everyone. My name is Oliver Tencer, and in this presentation, as Daniel said, I walk you through the latest updates in the design modules. These are improvements to existing modules, not brand new ones. So if you already own these modules and update to version X8, you receive these features automatically. Several design modules have been enhanced with new features. The SD1 and TD1 modules now include extended capabilities for backlink analysis, while SD1 also introduces methods for cross-section classification. The reinforced concrete module have been updated as well, further expanding the design capabilities. Additionally, the SC1 module has been extended with 2 important new features. One key update is a new method for defining the backlink length factor, which has always been one of the trickiest parts of steel member design. Previously, we had 2 options. You could select a predefined case manually, like pin-pinned, fixed-fixed, or fixed-free, and use the corresponding factor. Or you could let the program estimate the factor based on the stiffness and boundary conditions of the connected elements. That estimation was useful but not always precise, especially for complex structural arrangements. Now there is a major improvement. By running a numerical backlink analysis, the program helps you define a much more accurate backlink length factor. What's new is that you no longer have to rely solely on visual interpretation of backlink shapes. The program now provides quantitative sensitivity indicators to guide your decision. Let's break down these 3 new sensitivity factors. The direction sensitivity factor shows how much the backlink shape aligns with the direction you're checking, for example, in the global Y or Z direction. If this value is close to 100%, the buckling occurs in the intended direction. The structural sensitivity factor tells you how much the specific design element participates in the buckling shape. If this is low, it means the mode primarily affects other parts of the structure. The shape sensitivity factor combines the two previous factors. It's the most important one. It indicates how relevant a given buckling mode is for the design of your selected element in the checked direction. The higher the shape sensitivity, the more meaningful it is to use the buckling mode to calculate the buckling length or factor. You can run the buckling analysis based on different load cases or combinations and analyze either the entire model or a selected part of it. Once the analysis is complete, the program visualizes the result using green bar charts representing each sensitivity factor. This way, you are not just guessing based on visual shapes, you are working with reliable numerical indicators. Determining buckling length factors manually, especially for design elements within complex assemblies, can be highly uncertain. This new tool provides a more precise and more automated way of assigning buckling lengths that directly improves the reliability of your design results. Another improvement in the SD1 module relates to cross-section classification. As per Eurocode, sections fall into one of four classes. The classification depends on whether the element is primarily subjected to axial force bending moment or a combination of both. This new feature allows you to choose the dominant action type for each structural element. Based on your selection, whether it's axial force bending moment or the combination, the program calculates the section class accordingly. This gives you greater control and accuracy in representing the real behavior of your structure during design. Class for cross-sections, where parts of the cross-section buckled before reaching yield stress, were historically harder to manage. Now, the program calculates von Mises stresses for effective sections, taking into account the local buckling effects. This enables a more accurate design for these slender elements. The design calculations for SD1 were extended, which now includes the classification of each sub-element and a clear visual of the effective cross-sections, showing which parts are reduced due to buckling and which parts remain effective in load-bearing. For example, in this case, we're seeing a compressed class for cross-section with a clear illustration of the effective width. The TD1 module has also been updated with the new buckling length determination feature introduced in SD1. This means the same method using the same sensitivity factors can now be applied when determining the buckling length of timber design element, just as it is in case of steel design elements. In the SC1 module, two significant new features have been introduced. First, weld checks can now be performed on hollow section connections, expanding the range of connection types that can be verified. The second major addition is the optional replacement of beam end releases in the global model with joint stiffness values calculated in the steel connection manager. This option is not available for all connection types. For example, nominal pin joints are excluded, but it can be used for end plate or base plate connections. The desired joints can be selected directly within the steel connection manager, and the replacement will take effect after exiting the Steel Design tab or upon saving the model. Now let's take a look at the latest improvements in the punching analysis module. The update introduces new methods for evaluating the outermost shear reinforcement perimeter, U out. First, let's see why these new methods were implemented. During punching shear design, we calculate U out, the perimeter beyond which no reinforcement is required, based on Eurocode 211 formula 6.45. This is a theoretical length, independent of actual geometry like nearby holes or slab edges. Next, we locate this U-out perimeter in the real slab by iteratively moving away from the supported surface and measuring the corresponding UI perimeters. The method assumes perimeter grows with distance. However, in complex geometries, the UI perimeter may never reach U-out, causing the process to fail. The new methods address this limitation. So to handle these kind of situations, we have introduced two new methods. As the geometric properties are given, an alternative option based on 6.4.5 of Eurocode is to decrease the punching shear moving away from the supported area. The first method allows for a direct summation of shear stress along the perimeter. The second method takes into account the slab self-weight within the examined punching perimeter, reducing the calculated shear force accordingly. Moving on to the next update, an enhancement in the reinforcement verification process for concrete columns. Previously, reinforcement positions had to be manually defined for each column, which could be time-consuming. Now, with the new reinforcement scene wizard, users can create and assign predefined reinforcement layouts for both rectangular and circular cross-sections. For circular cross-sections, user can specify the rebar diameter, the number of rebars, and define the rotation angle. For rectangular cross-sections, the wizard allows customizations of corner rebar diameters, as well as the number and diameter of intermediate rebars in each direction. Different embedment depths can now be specified for the sides of pad foundations and strip foundations. This allows for situations to be taken into account where, for example, the cover depth is not uniform on all sides, such as in the case of the basement level, for example. For pad footings, the varying embedment depths can be defined per quadrant, indicating where the higher or lower cover depth applies. The foundation cover depth can consist of two different values, D1 and D2. These values can be assigned by clicking on the top view diagram of the foundation. For pad footings, the values can be assigned to quadrants. For strip footings, to the individual sides. That would be all from my part. Thank you for the attention.
Thank you. Thank you, Oliver. And now I'm going to hand over the microphone to my colleague from the design team, Mate Kadar, who will talk more in detail about the new updates of the soil wind module and the Grasshopper to AXISVM version 8. Thank you, and on to you.
Hello everyone, my name is Mate Kadar and I will be presenting the latest features for the soil module, the wind module, and the Grasshopper add-on. Let's start with the soil module. With the X8 version, it is possible to model the initial state of the soil. Before the construction of the structure begins, there are already existing stresses in the soil due to its self-weight and pre-existing loads. These existing effects can be modeled in a so-called initial state. In this state, we take into account the stresses developing in the soil, but assume the deformations caused by these stresses have already occurred, so the soil's deformation in the initial state is considered to be zero. This slide shows a cross-section of a simple model. The top row shows the effective stress in the soil, and the bottom row shows the resulting displacements. In the initial state, only distributed load acts on the soil, and for easier understanding, in this example, the soil self-weight is not considered. It is clear that stress arises from this initial load, but deformation does not occur. In the second column, you can see that deformations and stresses that that develop in the soil due to the structural loads. The final state can be obtained by adding the effect of both actions. In the final state, it is visible that from the initial state, stresses develop in the soil, but deformation does not occur. The initial state can be considered in two ways. The first case is when only the soil model is used. In this case, the initial load case must be created, which only includes the pre-construction loads. The loads can only be directly defined on the soil, such as the self-weight of the soil or distributed forces acting on the soil. When starting the calculation, the appropriate initial load cases must be selected. Sorry. If in addition to the soil model, we also have the new STG model, the first construction stage itself is the initial state. In this case, it is possible to consider loads defined on the structure as well. For example, the slab foundation of an adjacent building can be modeled, allowing for us to more accurately account for the load distribution. Now, I will briefly show you how to define the initial state in practice. First, I will demonstrate the process when only the soil model is used. You can see that there is a load case called the initial state. In this load case, the self-weight of the soil is defined, as well as surface as line loads acting on the soil, simulating the effect of an adjacent structure. In the statics tab, when starting the calculation, a new window pops up. Here you need to select the appropriate load cases that represent the initial state. I only need one load case now. Finally, the calculation can be started by selecting yes. After the analysis is complete, the displacement results show that deformations only occurred under the structure. But if I switch to displaying the effect of the effective soil stress, you can see that stress was also created from the initial state. If, in addition to the soil model, we also have the STG module, the process is as follows. In this case, I have also defined the foundation slab of the adjacent structure and applied the loads shown earlier. I switch to the construction stages tab, and I select the first stage. In this stage, only the soil and the foundation of the adjacent structure are defined. The structure is built in the following construction stages. If I open the construction stages window and expand the first stage, I can set whether I want to consider it as the initial state or not. I can also customize whether only deformations or only stresses should arise from the initial state. I will stick with the only stresses setting. Starting the static calculation is the same as for any STG model. Once the calculation is complete, I get results similar to the one shown earlier. The displacement results show that only the structure causes deformation in the soil. But when displaying the effective soil stress, you can see that stress also arises from the initial state. Now I will summarize the new features released for the WIN module. In X8, a more advanced algorithm for checking mesh quality has been introduced. If the mesh quality is inadequate, many non-orthogonal cell connections may form. And from now, after meshing, the program checks the number of these poor quality cells. If the number is too high, it performs extra iterations on the pressure equations to ensure convergence. Another improvement is that now, after the wind analysis, calculation information is available. The data is available for every wind direction. A new important feature that in many cases, the results may appear correct at first glance, but they could actually differ from reality. It is also possible that the residuals do not reach the target value, but the pressure field still converges. To avoid this, a new build check-in provides feedback to the user about the reliability of the results. The feedback is based on the epsilon plus value, so-called the non-dimensional wall distance. This parameter shows whether the mesh is fine enough for accurate flow modeling. The results are considered acceptable if the value is below 300. If the epsilon plus value is too high, feedback is provided during the calculation. After the calculation, the epsilon plus value can be displayed on the model. If the value is too high in certain areas, feedback is provided in the info palette and under the calculation information in the result status section. Another improvement is that wall shear stress is now available among the results. From now, the model supports the UK's national adaptation of Eurocode. During the wind calculation, a progression indicator is visible on the taskbar icon, and additionally, streamline visualization settings can now be customized for each wind direction. The X8 version also brings several new features for the Grasshopper add-on. A total of 10 major improvements have been made, among which several smaller ones. I will now highlight only the few key new features in detail. For a complete list of updates, please refer to the manual. One important note that the new version of the add-on is only compatible with the X8 version. AXISVM components now provide a Rhino preview. Let me show this in practice. The current model is displayed in Rhino like this. When selecting an AXISVM component, its associated geometry is highlighted in the Rhino viewport. This helps visualize which elements belongs to each component. Let me show you some examples. Selecting a distributed load component allows for easy verification of which domains it applies to. Also, with the new feature, identifying columns with specific cross-section is now easy. And another related improvement that the material, cross-section, and CLT property selector components now display the selected property directly under them. Another new feature is that existing AXIS models can now be imported into Grasshopper. I will demonstrate a practical application using the previously shown model. First, I have to place the importer component, specify the file location, and we can start the import process. After the import, the model data can be extracted and modified. I will show a small example focusing on domains. I select a random domain from the imported model, place the deconstruct component. The output provides properties such as thickness, material, eccentricity, or contour lines. These properties can help us filter the desired elements. In this case, I filtered the horizontal domains using a predefined filter. You can see the horizontal domains here. I define distributed load on them and sent the modified model back to the original AXIS model. If another model were imported, the same filtering and load definition would automatically apply to its horizontal domains. In addition to the features just presented, 3 more new functions have been introduced in the model management and data import: creating custom model parts from Grasshopper, selecting elements in AXISVM from Grasshopper, and saving model variants in separate models. Regarding load assignment, 6 new load types have been introduced, as you can see. And additionally, 4 related smaller improvements have been made in this field. Overall, the focus of the developments were the better visualization, importability of models, introduction of new load types, and more efficient workflows. All new features are detailed in the manual. I would like to say thank you for your attention, and I will hand over the stage to Daniel Kish again.
Thank you very much, Mate. Hope this was interesting for you. And now we are going to go on to the last segment of the webinar, in which we'll talk more about the new view modes in AXISVM. And I'm going to hand back the microphone to my colleague, Roland. Thank you.
Okay, thank you. So to close off today's meeting, there are only 2 lighter topics left in the presentation. Both are linked to display options in AXISVM X8. First one is that we have clipping regions available in the software, which are available in the basic packages. So regardless of what configuration you have, this function is available for you to use. It is located on the sidebar of the main user interface, and basically it can be used to display a slice of the model, and you can apply up to 3 adjustable clipping planes. And it's similar what we already have inside the analysis dialog, which is the scanning options, but this is a more versatile tool. And the other one is that we have now a new option to display your model, which is the drone mode, which is a special display mode with which the viewpoint can move and even enter into the interior of the structure. You can record flight tracks with this drone and export these flight tracks into a video file, and which is ideal if you want to present your model, so you can create quite spectacular videos about your model for presentation purposes. And also there are some more practical use for the drone. So you can select elements with it. So basically, if you select an element, if you use the drone can fly to the element and find that element inside of your model. So I brought 2 little examples just to show these features. First one is my previous model, which was the model used for the construction stages. And on this model, I will show you the clipping regions. So here you have the option with which you can initiate the function. And after you click it, you will receive a panel on which you can turn on and off different clipping regions. If you click on one of them, you will receive 2 clipping planes on the top and on the bottom of the boundary of your structure. And on this slider, you have the option to move this clipping region and cut your model, basically. And by that, you quite easily can have, for example, a view on the floor plan of your structure. And these clipping regions can be used in the result view as well. So for example, if we have a soil modeling domain like here, we can easily visualize the, for example, the axial stresses underneath the structure. And you have a variety of options. You can turn on and off different planes to act simultaneously. And yeah, basically that's it. We can play around with the settings, so you have options to select other kind of colorings where the model is being cut. But basically, this is the core function of this feature. The other one is the drone mode, for which I brought you this model. And the drone mode itself is placed again under the on the sidebar under the clipping regions. And if you initiate the drone mode, you will receive a panel, on which panel you will see a top-down view and a side view of your model, and a small red circle representing your drone, and an arrow representing the view vector of this drone. You have some controls, which shows you what are your options to move this drone. And basically, you have two options to control the drone. You can either use the keyboard, or if you have an Xbox compatible controller attached to your computer, you can use that to move around with the drone. So with the sticks, you can move up and down, left and right. You can turn your viewpoint, and you can move forward and backwards, of course, with the trigger buttons. And basically, you can use this to fly inside of your model and check your model from a different perspective. What is really useful or really good in this drone mode is that you can record the flight path. So, for example, we have some predefined view of the structure, and if you click on this plus button, you can insert a camera point for this position. And we can add more of them, so we can have a side view. We can add that as well. We can have a top view. We can add that as well. And you can even interrupt this. I mean, you can even add your own positions. So for example, if I fly the drone a bit closer to my structure, I can add more of these points. And as I add these points are visible on the viewpoints. I mean, on the top and on the side view of the panel. And let's say I want to go into the garage. I can fly there. And after you have recorded some of these points, you can start playing it. And the software will create you basically a video file moving from viewpoint to viewpoint. And in this way, you can present your model in a new way, what you don't have the possibility to do before. Yeah, this is what I wanted to show you. And by that, we have reached the end of the presentation. And thank you for your attention. And I will pass the stage back to Daniel to close off this session and start the question and answer.
Thank you, Roland. We had the last section, the Q&A section. We already received almost 40 questions, so I'm sure that we won't be able to answer every one of you, but I will read in a few questions, and as mentioned before, we'll reach out to you directly to answer your questions to which we haven't had the time to answer right now and here. I will ask the team just everyone to come on to the stage just yet, and I will read the first question, which states, if I understand correctly, the construction stages should be organized in such a way that each stage contains only one type of code operation. End of question. And I think Roland will answer this one.
You don't have to do that. So basically, you can mix different kind of actions. So adding of elements, removing of elements, modification of elements inside one construction stage. But when it comes to the analysis part, the software will need to know that which is the first, which happens later. So if a construction stage consists adding elements and removing elements, it has to know that which happens first. And if it detects that there are construction stages which are mixed, then it will offer you a dialog where you can decide that which operation happens first. Addition of elements happens first, then it followed by the removal of certain elements, and you have to define this. And if you only have to define or decide what to happen, and the software will automatically insert new construction stages into the manually defined list. So you don't have to create them by yourself. The software will create that for you, but at the end you will end up having just pure construction stages containing one type of action. But you can mix them. Software will handle it automatically for you.
Okay, sounds good. Thank you so much. Then on to the second question, which states, if a line element is modified, say its material changes because, for example, a column is replaced, how can this be managed from the design side? Can the program handle two materials being associated with a single line element? Again, to you, Roland. Thank you.
If you mix, so if you modify elements and modify their materials, reinforced concrete column turns into a steel column, for example, you need to design, you can design that, of course. You can design using RC modules to handle the reinforcement part of its life cycle. And you can use the SD modules of the later life cycle of that specific element. And basically, if you select construction stage, and in that construction stage, that element is reinforced concrete, then on that specific construction stage, you will only able to use the RC module. And from a later stage, so for example, from the 5th stage, it's a steel member, then you will be able to use SD module on that element from the 5th stage. So you can do that, yes.
Thank you. Third question, after modifying a temporary bracing, do we need to run the entire linear static analysis again, or is there a way to run the construction stages separately? And I suppose it's you again, right?
You don't have to run the whole analysis from the start. You only have to run those construction stages which values were invalidated. So for example, if a column is changing from a certain construction stage, then the following construction stages, the results of these stages will be invalidated. But until that point, the first half of the construction stages will still be left unintact result-wise. So you don't have to run the whole range of construction stages from the start.
Sounds good. Thank you so much. Down to the fourth question. How is the effect of corrosion considered in the STG module? Do I need to manually specify the level of corrosion for individual elements?
Yeah, as I mentioned during my video presentation, you can take into account this effect indirectly. So there is no built-in function for taking into account the effect of corrosion, but you have a wide range of existing tools already inside of AXISVM. So if you add a reduced cross-section for a steel member representing the corroded cross-section, then in a modification process inside of a construction stage, you can use this reduced cross-section in the following construction stages. So this is how you can take into account the effect of the corrosion itself.
Thank you so much. And unfortunately, we only have time for one last question, which will be this one. It states concrete shrinkage and creep in stages, question mark. For example, tall buildings, vertical deformation of columns, 1, non-staged calculations, 2, stage calculation with taking into account concrete shrinkage and creep, 3, stage calculation with taking into account concrete shrinkage and creep. AXISVM will calculate number 3, question mark. Who's going to answer?
I'm going to answer it.
Thank you.
So the whole process itself has to be shortened down, because there is, at the moment, there is only linear calculation available for construction stages and non-linear calculation only available for the final state, the operational state of the structure of your building. So that means that there is no creep and shrinkage can be taken into account during the calculation. What I feel important to note that with the what we did with the soil module, what we did with the wind module, and now what we are doing with the STG module itself, this is the first iteration of the module, and and it is a very big module, very complex module, deeply embedded in the software, and we have plans to continue developing it as we did with the previous modules, soil, wind, and etc. So we talked about this one, if we can take into account nonlinear properties or nonlinear effects, and there is no objection in principle, or there is no barrier to do that. And this is a way what we want to continue, or what we want to implement in the future. But in this current state of the module, the first iteration, what you will have with the release of X8, it is not included. So you only have linear calculation for construction stages, and all of the functionality, including nonlinear calculation, for the final state. So that's hopefully answer your questions. And to assure you, we are continue nurturing this module as well as we are doing with the rest of our modules.
Okay, thank you, everyone. We are a little bit overdue, so I'm going to conclude this webinar right now. I would like to thank again our presenters, and I would like to thank you for your attention. We are going to answer all the remaining questions directly as promised, and we will share the recording of this webinar as well in the upcoming few days. Thank you again for participating. Hope you found something interesting, and see you in the future. Thank you so much.